Good morning, everyone. Welcome to the 5th AATF Technology Tuesday webinar. Today, we have another great presentation from IDX. The exciting webinar discusses all the ancillaries surrounding the digital communication systems used within building automation systems. They will delve into the various types of digital systems, the interconnection of disparate systems, proper implementation of data lines, getting data out of proprietary systems, and making building automation systems IoT. Our presenter today is Carl Roos. Carl's main area of focus is industrial and commercial Ethernet or field bus advanced troubleshooting and diagnostics, design, reliability, and maintenance solutions. He is an internationally certified trainer for Profibus DP and PA engineers courses, Profinet engineer courses, Modbus, KNX, CAN bus, Ethernet or IP, and he is a communication solution development specialist. During the session, please feel free to use the question and answer functionality at the bottom of your screen, and your questions will be answered after the presentation. Without further delay, I will now hand you over to Carl.
Hey guys, let me just quickly share my screen and start the presentation. Sorry about that. Cool. Well, thanks so much for everybody for joining, and thanks for having me. So today's discussion, and thanks to Letitia for the introduction. Today's discussion will be around digital communications in building automation systems. So today we'll discuss digital systems and their role within building automation and control systems. With the limited time we have today, I'll take you through a couple of scenarios and challenges that you may face and how these can be easily navigated. For the context of today's discussion, digital systems is a term I'm going to use interchangeably with communication protocols and technologies. These are languages used to share data between various different building automation components and assets, and how these systems are able to reach one another. But I'm more focused on the language traveling on the wire through the radio waves in the air, modulated on existing power lines and infrastructure, or even pulses of light through fiber optic cables. So let's begin. Digital systems in building automation are developed and implemented to allow components to share information, their states, and provide some sort of control. This making a particular scenario in your building, home, hotel, whatever it might be, a little bit more smart. So there are millions of scenarios, smart components, controllers, use cases, but let's look at the possibility of getting and using the power usage data of a building with a power line or meter device. So here I have a power meter connected to my energy lines. It's measuring 65.3 kilowatts. Now, why would we need to share this data via digital systems? Well, it could possibly be for load management. It could be for energy efficiency procedures, maybe just for the optimal use of renewable energy resources, such as solar or potentially wind power. Yeah?
Your screen isn't sharing. Could I just ask you to share your screen there?
Is my screen not sharing?
It's not, no.
Let's have a look, yeah, quickly. Aha, I didn't press the share button, I'm sorry.
No problem.
Okay, can everybody see my slide?
We can now, thank you so much, Carl.
Cool, I apologize about that. Thanks so much for jumping in there. Well, you haven't missed much. It just was an introductory slide. So within a building, there are a few, let me just minimize this. Within a building, there are a few location and range determined digital communication spaces. The three displayed above the slide over here are PAN, LAN, and WAN. PAN stands for Personal Area Network, and we'll start there. Typically, this is used when the user has a connection to a device or a system within the same room. Common PAN communication technologies are Bluetooth, Wi-Fi, serial, Ethernet, wired comms, or even infrared, a remote which you use to turn on off your TV every single evening. And in this scenario, you have a cell phone, Bluetooth enabled, that's able to read the 65.3 kilowatts directly from the device, making a direct connection probably less than about 10 meters. The next range up from PAN is something called LAN, stands for Local Area Network. This can span over a few hundred meters, can interlink tens to hundreds to even thousands of devices. Very often, this requires a more complex connection technique, communication protocols, where we're focusing on today, basically languages to be able to share across these larger distances. Various different addressing techniques need to be implemented so you can reach devices, pretty much like a postal address. And there needs to be compatibility between devices. In other words, the devices that all need to speak the same language that I keep talking about. LANs are used to connect all devices typically within a building, home, factory, allowing network interoperability between devices. Some of the technologies used in LAN communications are Ethernet, serial, wireless, or even something called PLC, power line communications, where you don't actually have to run a separate wire to connect devices together. You can actually run it over your existing power infrastructure within your network. There are various different wireless technologies such as Bluetooth, Bluetooth Mesh, Zigbee, and we'll come to those in a little bit. So we'll look at the LAN communication protocols in more details over the following slides. Some subcategories of a LAN, which we could refer to as something called HAN, stands for Home Area Network. You get SAN, which is Storage Area Network, WLAN, which you might be familiar with, stands for Wireless LAN. And even something called CAN, stands for Campus Area Network for the interconnection. I know this is a ton of acronyms, but just helps us to describe what section of a connection we're creating. The next range up from a LAN, which is linked with this purple wire, is something called a WAN. And you'll see that there's actually a little black device here linking the purple and the red cable. This would often be typically referred to as a router. It's a device designed to interlink a smaller network or a local area network, which could be in your building or your home, to the internet, where there's millions and billions of users, and allows the routing of the data between those a very, very large network and a smaller local network. Now, for the context of this discussion, we can also refer a WAN as an IAN, which stands for Internet Area Network or Cloud Area Network. WANs typically span over many kilometers and connect your smart devices and building automation systems to a global network, as well as remote servers, as well as commercial cloud services, such as AWS and Azure, where they have many different powerful tools allowing you to do something different and smart. A common application for this in your homes would be when you access your CCTV cameras via an app on your phone. So while you're out, you can see what's happening at your house. Turning on and off your lights with some smart low-cost relay, which has a Wi-Fi connection via an app on your phone. And even a lot of air conditioning units nowadays are WAN ready, where they have sort of a Wi-Fi interface, and you can remotely control and turn on and off your aircon when you leave the office to make sure that your home is at the optimum temperature when you get there. WAN can connect your smart components via a LAN-based network using this device, such as a router, but very often devices actually can directly communicate into a WAN network where they might have a Wi-Fi interface or a 5G or LTE interface if you want to utilize the service providers utilizing a SIM card to publish data directly to a wider area network for some sort of application. Now, briefly touching on the cybersecurity aspect within building automation systems, there's often very little risk when it comes to a LAN-based network. The only risk in a LAN-based network would be system malfunction and typically user error. Reason being is a LAN network is by itself, not connected to a WAN, is isolated, which means there's only a couple of users within the building operating that system. You don't have external users who you don't particularly want access into that system. However, a lot more security aspects need to be considered when we're connecting our building components or communication networks to a wider area network. We need to understand the devices linking to a wider area network. We need to understand how they work, what security standards or mechanisms are implemented into these systems. More to particularly this router which we're referring to over all this device, how do they protect your local area network from a much larger network? So the things which I'm referring to is like the use of firewalls, data encryption, two-factor authentication, password protection, just not leaving your router on admin, which I think a lot of us do all the time. And I mean, the security aspect is something that we could spend hours talking about, and maybe it'll be another really good webinar topic. But it's very important to consider when connecting your building automation systems to a wider area network or to the internet, that there's the proper security procedures in place. So understand the devices which you are using in that situation. But in the same scenario, we can transfer data either between devices within our local area network, our building, to be used by maybe a computer application. This device is representing a type of controller or a device that can make smart decisions based on what it's reading from that power meter, maybe turning on and off loads because the power usage is too high. And then maybe we can just do some remote storage of that value, or even remote access and visibility of that value using wider area networks to when you are not within the building premises. Now, let's dive a little bit deeper into the LAN communications, because that's the main topic of my talk today. More specifically, some of the communication protocols, languages developed to share data between the components within this local area network. So there are two main categories for communication protocols or languages, which I keep referring to, operating in this LAN environment. The first is something called a proprietary protocol. These are typically locked into a single manufacturer or vendor. The standards are not typically published or made available to other manufacturers to implement into their devices. Now, this is a challenge because it provides a user with very little flexibility to choose the best components for the application they want to control. So in other words, if you bought a device from manufacturer A for your building, that device would typically not be able to communicate with anything other than manufacturer A devices or systems. That's a bit of a problem. It gives these companies a bit of a monopoly, which is going to be a problem for us on price, compatibility, and again, flexibility to do what you want to do to optimize the application that you are busy with. Now, wouldn't it really be great if manufacturer A devices were able to communicate with manufacturer B, C, D, and even E, allowing you to pick and choose what best suits you? It turns out they can. The next main category is something where we refer to as standard communication protocols. These are openly published technologies which any vendor can use and implement, and allows seamless interoperability between the various different systems. How these protocols often come about is various different manufacturers of these smart components would come together. They would create an organization and they would put a couple of smart people to work to develop the standards and protocols, create a paper on it, and then make that paper available to anybody who would like to develop a product and implement that logic or that language into their system. And now if two different manufacturers speak the same language, they are able to communicate with each other. So within a LAN environment, we can also mention isolated versus integrated networks. An isolated network is typically only a few devices linked together that directly require one another to perform a task. Isolated networks are not linked to a larger building-based network. It might only span over a single room, for example. An example might be an occupancy sensor that is linked to a light relay that is linked to maybe a room-specific HVAC controller, so heating, ventilation, and cooling. This gives the resident who uses that room the ability to control heating and cooling, to turn on and off the lights, and also provide some energy efficiency because maybe it could turn off the aircon unit or turn off the lights as soon as it detects that that user is not in the room anymore. Isolated networks don't require much planning or design before implementation. Maintenance is very easy with fewer devices, and you often don't require specialized components such as switches or repeating devices that often require quite a bit of setup and can cost quite a bit of money. but isolated networks are locked into themselves. So the second type of network would be something called an integrated network. This would typically be a spider web of linked subsystems or sub-isolated networks, I suppose you could call it. And these subsystems might not be directly dependent on one another, but it can be very useful to link data and functions across an entire building. Integrated systems require in-depth design and planning before implementation. They require sound networking techniques and often specialized components to properly segment and isolate the various subsystems. This will prevent excess like network loading. Sometimes networks can get a little bit too busy and can cause communication problems with each other. They create things like collisions where two devices try and use the same cable to communicate at the same time. And in our same example where we're talking about a hotel, an integrated network could provide a centralized control resource of the entire building's HVAC systems and lighting systems. This would probably improve the overall energy efficiency of the building, guest experience even a bit further. So for example, the hotel staff could turn on heating and cooling in a room as a guest arrives for their check-in. Well, the check-in takes a bit of time, the room gets the optimum temperature, thus optimum efficiency and best guest experience. It could provide centralized metering and power load management, especially when integrating renewable energy systems and energy systems not dependent on the grid, such as generators, which have a finite power output usage. Now, let's look at some of the protocols used within these building automation systems. I've listed in the slide a couple of the common standard building automation communication protocols. I mentioned a little bit earlier, you get a couple of companies that would create an organization. This is some of the organizations which have released technologies into industry that we most commonly use in building automation type systems. I've split the protocols by the most commonly used technology medium for communication. It's important to understand the difference between a protocol and a medium. Medium is just a method that the protocols can use to transfer their data or to speak their language across. And the mediums which I've given an example of here is Ethernet based, very similar to this standard office Ethernet that would plug into your laptop or your PC, serial based, and wireless technologies, or the common use. And what you'll notice is a lot of the times the names are repeated across all the different categories, and that's true. Something like BACnet could have an Ethernet-based standard, it could have a serial-based standard, and it could even have a wireless-based standard, depending on what you want to do, but it's still the same language, it's just using a different method to communicate. This is by no means an exhaustive list. There is hundreds of technologies out there, and a ton more have popped up in recent years during this whole IoT era that we are currently in. Some exciting stuff is happening. I've also not included any of the common proprietary protocols, which we mentioned in the previous slide. So now, some of these protocols, for example, Modbus. Modbus is not only used in building automation, although it is very useful. It's also used very commonly in the industrial environment, home environments, and many more. Mqtt, also used very often in the IT environment, can be used to link directly to servers on the other end of a WAN connection, meaning that it can operate as a language not only in your PAN space, but also in your local area network and in your wider area network directly. Interoperability of these protocols is allowed through common protocol implementations within devices. So what I mean by that is, if device can speak BACnet, for example, and a device B can also speak BACnet, these devices are able to communicate with each other if they're connected to the same cable. So with little integration, if I connect multiple different devices together that can speak the same language, then it's very easy for me to get them to share and communicate data. Most of the technologies listed have different substandards, allowing them to be compatible through different mediums of communication. So for example, the Ethernet variant of KNX is something called KNX Net IP. And this is able to communicate between KNX components in a building through the standard office and building Ethernet infrastructure. I could even share the same Ethernet infrastructure. The serial variant of KNX called KNX TP stands for KNX Twisted Pair referring to the type of cable which is used to connect them. That's a serial version of KNX, and that's actually the most common implementation of KNX, because I can connect a ton of KNX devices and it's very easy to link and implement these together. Then you have a wireless version of KNX called KNX RF, or radio frequency, stands for RF. And you even get a version of KNX called KNX PL, stands for KNX power line, which actually uses your existing power infrastructure in your building and superimposes a signal onto that power line to connect KNX devices. So you don't even need to run KNX wire between those devices. Many different options depending on what you would like to do. So here are some of the logos which you may have recognized. You might have seen it around, heard about it, or might be new to you. And these are the most common communication languages and standards. The most popular protocols within the building automation sections are typically KNX, LonWorks, and BACnet. MBus is typically used for metering, for water and power metering. It's used in commercial shopping centers and large residential flats, things like that. This allows automated reading of meters for power usage and then the generation of bills. It's also used quite a bit for load shedding and power and water management. Modbus is generally an easy all-round protocol that can be easily implemented into any device. You probably have a Modbus-enabled device at your house and you don't even realize it at your house or your building. You might not even be using the Modbus interface, but comes Modbus ready because it's very easy to implement into the system. Things which would typically have Modbus interfaces could be your generator controller can often talk Modbus. You might have a power meter that can talk Modbus, or even a UPS backup system connected to your servers, or very well will be Modbus ready. DALI is very often used in the lighting and control space. In Ocean is used for energy management. It's a wireless-based technology. LonWorks, although LonWorks can be used by multiple different vendors, it's actually also a proprietary-based protocol, as the standard is not open and freely published. Only members who are members of LonWorks can implement the LonWorks Neuron chip into their components. So you need to join that organization that I was talking a bit about in order to become a LonWorks device. Zigbee, although Zigbee is not really a language like I keep referring to, it's a technology very similar to something like Bluetooth. Bluetooth will probably be the biggest competing technology of Zigbee. This is a low-cost, low-power wireless mesh technology, meaning they can connect to multiple different devices to intercommunicate. And it's used very commonly in building automation networks to create PAN, so personal area networks, and LAN, local area network connections between components. Technologies like BACnet use Zigbee for wireless comms in some instances. However, many manufacturers and integrators can actually leverage this technology without much work to create custom powerful applications for your building. Mqtt is a lightweight open standard used to publish and subscribe to data over a network. This could be for PAN, LAN, or even WAN-based networks. Most commonly, Mqtt runs over Ethernet infrastructure using something called TCP/IP to create its connection. However, there's many network protocols that can actually run Mqtt comms, and it's a very compatible protocol, becoming very popular for IoT applications nowadays. Now, we already understand the challenge with proprietary protocols not being able to communicate between the various different manufacturers. But what happens when you want to interlink devices that talk different standard languages, such as I want to connect for example, a Modbus power meter, which I've been referring to maybe a KNX building controller. I have a KNX controller that can do something smart with the power usage from that. They're two different languages. So how could I connect those together? So in this representation, this power meter over here, measuring my total power usage, can talk Modbus. My controller can understand KNX, but these guys actually can't communicate because the languages are mismatched. They wouldn't actually be able to share data between themselves. So you would probably need some sort of like translator, a device that could understand Modbus, a device that can understand KNX and can actually read in the Modbus data and retransfer it out as KNX data. There's two different languages. So there's actually a company that we have aligned with, a company called Intersys, that's merged with HMS, that creates gateway solutions for building automation controllers. And they've created gateways for all the different protocols which are referred to in this slide, that can talk all these different common communication protocols and quite easily share it between the two different systems. And setup and configuration of these type of gateways is very simple and straightforward. So by using a gateway, I can actually take two different types of technologies. If that building automation component is optimal for what I want to do, and maybe it could be a cost-saving thing even, using a gateway to expand that network and to share data to do something smart with it. Sometimes it's just not as simple as chucking it in its gateway. And where IDX is typically specialized is creating custom protocol gateways or solutions that can interlink disparate systems. So I might have a component or a parameter that talks maybe an undocumented protocol or language, or maybe it could be a legacy system that isn't really supported anymore, or it could just be a custom device that didn't implement one of the common standard protocols, but just maybe something that the developer decided to use at that situation. So then we chuck on our IDX hat, and we actually work a lot in the space of creating these custom gateways that can interlink systems that are not standard. So we create unique gateways in industry. And what's really great in this application is that devices like this can also integrate things like historians to store that large amounts of data, or even publish that data not only to our KNX controller, but maybe to now a third-party commercial cloud service to integrate into apps and things like that. Now, we can have a quick look at the proper implementations of data lines. And working a lot in the industrial environments, a lot of my day goes around working in the mining, food and beverage space when it comes to their communication systems operating plants as well. And you find very quickly that there's not too much difference between the communication protocols used within industrial environments to what's used in building automation and control environments. Very often the communication protocols overlap, but the same standards and requirements that are used in the industrial space need to be considered even in a commercial and building automation space. So I've titled these tips as tips for low cost of ownership. And where you talk about low cost of ownership is when you implement a system, you want that system to work for you. You've implemented it because you want optimal energy efficiency. You want maybe the best guest experience, or you want a certain application to work for you. And if it isn't implemented correctly from the beginning, it's going to give you industry issues, it's going to cost you money to repair, and it's ultimately not going to be giving you that return on investment that you implemented the system for initially. So some of the quick tips which we can consider here. So install according to the technology specification. These organizations that release the standards, that publish it, which can be many hundreds of pages and can be quite daunting to go through. They are very important, and they've developed because they've spent a lot of time testing in laboratories and understanding how the systems are supposed to be properly implemented. So a quick way to get around this is use companies that are competent on these systems being installed. They need to understand and implement according to the relevant standards and guidelines. And where possible, check that the company doing the installation in your companies is certified for the technologies. For example, KNX, another one of these organizations, has done a great job at creating training centers all around the world. And what they would typically do is they would share some of, you would sign up and you would study the KNX standards, these many hundreds of pages, become very competent, work with it, create training rigs, and then you would ultimately get audited by the KNX organization to check, are you competent to teach people how to use the system? So now when you get a KNX training center, somebody can come through and attend a 5 or longer course, 5-day course, and work with the systems in there and understand exactly how to properly implement them from the correct side. So if possible, and there is training available, check that people have those certifications. IDX is a certified KNX training center for both basic and advanced courses. And we've done a lot of training in the Modbus space. There's a lot of industrial protocols that we've done, relative industrial Ethernet, but whether we offer the training or maybe there's a third-party technology that can offer the training, and very often the large vendors that supply building automation components can give training on those systems as well. Do some research into it, and if you are an integrator, jump onto those training sessions. your value from it, not only for the specific technology that you're learning on, but taking learnings out of that and applying it to other systems as well. All these systems work in a very, very similar fashion. So generally, when you understand one Ethernet-based system or one serial-based system, you can apply a lot of those values to other Ethernets and serial-based systems. Use the cabling, network components, and devices that meet the installation criteria, right, as laid out by the specification. And cabling, I found, is very important, especially when it comes to serial-based systems. Very often, a cable, for example, a KNX type cable, has specific electrical properties that are associated with it that are designed to carry that signal and to carry it optimally. So you can't just use any standard cable just to connect these devices together. You need to use the correct network components. So using quality components, for sure. You don't have to spend the most amount of money on and get the most highest end product for every single application, but definitely take into consideration using the more reliable vendors. And it's almost that one saying, if you spend the lower amount, you're going to end up spending the higher amount anyway. So ensuring quality components, especially in critical implementations, is often a very good process from the start. Wireless technologies can be very fussy, and the reason that is because typically wireless is not a static environment. It's constantly changing. Wireless isn't just hardwired, so it has to go through walls. Very often there's competing wireless signals around that can actually affect that wireless signal as well. So it's very important when you want to install a wireless application, especially when it spans throughout a building, is doing an audit of that wireless installation prior. So installing maybe a pilot wireless, or getting somebody who understands wireless systems and getting them to test the signal and the quality of that signal traveling from point A to point B in the network, and whether that's actually going to work for that application. And if not, maybe you need to look to do something different. Wireless can give you a lot of flexibility, but you need to ensure that the installation which you're doing is correct from the beginning. High voltage cables, your 220 volts or 400 volt systems in your houses for three-phase systems is considered high voltage, and digital cables typically do not mix. And the reason being is these high voltage cables can actually affect the signals traveling on those. So you cannot typically share cable trays, and you cannot share conduits between your high voltage cables and your communication cables. And this is true in most instances, except for, I'll put a point here, PLC, power line communications, where you're actually using your power line infrastructure to modulate a signal between different components in your network. But when running your cables, something that I see all the time is just making sure that you do separate your communication cables by a few centimeters from your power cables, and not actually running them right next to each other, because that causes very often a lot of issues. And now, when you're looking at Ethernet-based networks, having good networking principles and proper segmentation of these networks, especially spanning over larger buildings, becomes very important. So getting the specific IT, very knowledgeable people on these network isolation principles. As I mentioned, you can get some network overloading and collisions that can create a bit of problems for you. And so the last point I want to chat into sort of IoT and building automation. So now, wouldn't it be cool if you had an existing smart building component like your Modbus power meter or building communication network running, and you're able to remotely access it, control or monitor this device from anywhere in the world on your smartphone, laptop? Turns out you can. Let me show you how. So there's various different components within your building or home factory have smart communication interfaces, such as power generation components, such as a diesel or petrol generator, maybe a UPS system. You might have a solar system installed in your building, and those solar and inverter systems very often have smart communication interfaces, the protocol of which is often a little bit more proprietary and something a little bit different. You get sensors, so you could have your power meter. You might even have a lux sensor, which can measure how bright the sun is out to make decisions on your solar system, or even occupancy sensors to determine is somebody in that room or not. You get your HVAC system, so your air conditioning units. And then you get your actuators. So maybe your a couple of switches to turn on and off lights remotely, open blinds or close them when the sun is blaring onto the side of a building, controls lifts, automatic doors, or even access control for the security-based systems, which I suppose could probably link into the CCTV systems as well. Now, as I mentioned, very often these type of systems have communication interfaces already built into them, or straight out of the shop. So in this case, my generator at the top here has a Modbus interface. My power meter has a BACnet interface, as well as my air conditioning unit. And then on my lighting controller over here, which you can turn on and off light, also has a Modbus interface. So Modbus TCP, Modbus RTU, which is the serial variant of Modbus, is the Ethernet variant of Modbus. Your Ethernet variant of BACnet, or your serial-based variant of BACnet, can all link into another smart device called the Intersys ST gateway. And the Intersys ST gateway comes ready with a Modbus interface as well as a BACnet interface, can understand those languages. And it can quite easily, with quick configuration, fetch data out of these systems and publish them to an ST cloud, which is a freely available cloud service with the Intersys ST gateway. And why this is great is then within the ST gateway, you can create a dashboard which allows you to remotely access your temperatures or your power usage. You can turn on and off lighting systems or see the states of lighting systems, set various different temperatures, or even just see is the generator running or not. And you can start doing some clever implementations from that. So some quick, fantastic solutions out there to very quickly get your building automation system to work for you and how it should. And here's some of my details. As I say, this is a brief webinar. We do tons of topics all the time. If there's topics that you guys are interested in, whether it comes to cybersecurity on building automation systems, or you're interested in more details on Modbus, CAN, Ethernet-based systems, feel free to drop me a mail or to reach out to us, and we're always happy to share information and to have a discussion with you. You can check out, we publish various different articles giving some information on our blog.idx.co.za. Follow us on LinkedIn. Check out, we do have some training videos on YouTube, specifically on like Modbus protocols if you're interested more on that. Or you can jump into our website or drop me an email as well. And what I'll do now is quickly jump into a Q&A. So there might be a few Q&A questions popped up, but if you see at the bottom of your screen, there's a Q&A button. So use that and not the chat. And then I'll see if I can offer that. Cool. So do you offer training on these communication protocols? So as I mentioned, we do offer KNX. We do offer KNX training. So we are KNX certified for basic and advanced KNX training. We also do offer Modbus training courses, and we have a general Ethernet-based course which just teaches you the principles of Ethernet as well. But for more product-specific training on BACnets and that, typically no. You might get that a lot from larger vendors, but hey, reach out to us if there's something that you're interested in. We do a lot of training in the industrial space, and we have quite a bit of competence when it comes to these communication protocols. You mentioned doing audits before implementing systems. Are you able to complete a full audit for my company? So yeah, we have competence when it comes to Ethernet and serial-based systems. If you have an existing building automation system and the communications are giving you hassles in that case, we can very often fault find on those different systems, as well as just give an overall health analysis of it. What we have typically found in the past, also in the industrial space, is when a company has a system integrated to install a large critical system, they'd often get us out just to go through the system, ensure that it's installed according to those specifications and guidelines, which I mentioned a little bit earlier. And once that the system integrator has finished that, and we can give a full report and confirm and do that before sign off. So that's another answer. How can building automation communication systems assist with energy efficiency and power management? So we can jump that into two different sections. So obviously building automation systems in the simplest form would be able to turn off various different systems if they're not being used in that current scenario. So for example, if you don't have a user sitting in his hotel room, you can turn off the heating or the cooling, which uses a huge amount of energy, or the lights, and only turn it back on when that user enters. But maybe we jump it into a different section where you could look at power generation systems such as a generator or an inverter system. These have a limited amount of power outputs, and they're often rated to a certain amount of power output. So it might actually be useful that you could use these digital communication systems to share data between your generator or your inverter system to some load management devices that can measure what is my finite amount of power available, what is my total usage available. If my power available and my usage is starting to exceed the power available, maybe I could make some smart decisions and turn off things that aren't critical at that point, because you don't want to over exceed what is currently being supplied. So for example, turning off a geyser or a HVAC type system which isn't being used for a critical situation, in that case might be useful as well. So yeah, I think it has a pivotal role when it comes to power management. Mr. Naven asks, with these disparate systems, where would OPC fit in? Nothing that is more of an architecture, set of standards and operativity, as opposed to a specific protocol. So typically we would have OPC DA in the past. OPC was basically a more Microsoft heavy system, and now more readily in the recent terms we got OPC UA, which is cross-platform. And I think OPC definitely does have a space in building automation systems, because it can be used to share data across many different types of systems. It can probably be a common communication interface between different disparate systems. If you needed almost, I suppose you could call it a bridge or a tunnel between those different systems. So OPC UA is definitely up there with like the whole Mqtt as that common IoT type language, especially with the amount of flexibility and associated supporting data, which you can use in OPC. Thanks so much for the question. Can you assist us with the building automation equipment and installation? So IDX typically we are not system integrators, and we don't have too much interest in working in that space. We work mainly on the training of the communication systems, testing and fault finding of those systems. And as for building automation components, we do work a lot with gateways connecting these different communication systems. I suppose some minor switches and routers and things like that, but typically not the building automation components. No, it's more connecting building automation and working on the communication state itself.
Thank you, Carl. Does that bring us to the end of our question and answer session? Let me just see, I see one more flag there.
I think there's one from Dion. Am I correct in saying that you have DALI 2 gateways, like that of DALI? Dion, I'm not 100% sure on that question. If you could drop me a mail, I'll see if I can find out the answer for you. But you know, I'm not 100% cleared up on the DALI automation protocol, unfortunately.
Great. Thank you, Carl. That was a very informative presentation. We will now.
Thanks, Letitia.
I would like to just sort of ask everyone to use and answer our poll question, which will be coming up on the screen shortly. We'll just take a moment so people have a chance to complete those. That brings us to a close. Thank you for attending our 5th AATF Automation and Technology Tuesday. Thank you to IDX and to Carl for an informative and knowledge sharing session. We would also like to remind everyone about our next AATF Technology Thursday presented by ePlan on the 13th of August.